polynomial function has to have whole number powers, so it can't have rational powers and roots in there. It can't have negative powers, okay, so it can't be rational, and it has to have whole number coefficients. Okay, so technically that's how we define a polynomial function. So these would be examples of polynomials. These would be examples of non-polynomials. So there's a rational function here, a root function here. And one of the main characteristics of polynomial functions is as the power increases, okay, we increase the number of bends or arms on the graph. So degree 2 has 2 arms like this. Degree 3 has these 3 arms. A degree 4 gives us these 4 arms. Degree 5 has 1, 2, 3, 4, 5 arms. And this shaping of the graphs also gives us an indication of the number of possible solutions or number of possible times it could cross the x-axis. Okay, and again, it's important to understand this connection between degree and shape, and between shape and number of solutions, because the number of solutions is actually what's key. So when we talk about the form of the polynomials, there's a general form, and then there's a factored form. Okay, the general form has very little information it gives us. Now, it does give us some information. So if we kind of look back at, these polynomials we've seen in the past here, okay, that plus b told us the y-intercept. Okay, this plus 4 on a quadratic gave us the y-intercept, because the y-intercept is when x equals 0. When I plug in 0 here, I get left with b. 0 here, I get left with 4. If I plug in 0 into a cubic, I'm left with 1. If I plug in 0 into this, I'm left with plus 5. So that last constant term actually is the y-intercept for any graph. Okay, so that plus 9 here, this plus 9, if I substitute x is 0 for the y-intercept, I get 0, 0, 0, plus 9. So that must be the y-intercept. So the general form does give us some information about the graph, and other than the degree, it tells us, the y-intercept. But that's really of limited use and limited information. We're really interested in shape and also the roots, or where across the x-axis. And the factored form is really going to give us a better indication of where it crosses the x-axis, because it allows us to find the zeros of the function much easier. So this factored form, we can still get the degree because we can see x is multiplied by itself 3 times, so it's a power 3, degree 3. And we can see from the factors what our roots are going to be. And this is key. This is what we want to start getting into. We want to get the factored form. We want to be able to factor these so that we can see what the roots look like and how we can solve equations when they're equal to 0. So that's going to be our goal in the long run.